Everybody say hi to Cameron.
Hi, Cameron.
Make it friends.
Hey, say good luck at state.
Good luck at state.
All right.
I love you.
All right. Okay. So 13 divided by 4 is 3. Listen, you guys. 3 remainder 1, or 3 and 1/4, right? Okay. So we go to the next slide. 14 divided by 4 is 3 and 2/4. So 3 remainder 2. Remember that? And we can write that as 3 and 2/4, which is 3 and 1/2. 15 divided by 4 would be what? 3 remainder 3. So 3 and 3/4, right? And 16 divided by 4 would be what? 4 with a remainder of 0. Now, this is what we're going to be talking about today. We're going to be talking about mostly remainders of 0, but we're going to talk about other remainders as well. This is what we're going to be doing, except for we're going to be doing this with polynomials. Got it? We are going to be doing this with polynomials. So, you guys know how to do this with real numbers? We're going to do this with polynomials. So, going back to this slide right here, you're given a polynomial p of x. So, let's write a polynomial p of x, shall we? Okay. By the way, I'm going to have to make this up as we go because Coach Adamson had to come in here and fix my computer during my prep hour and I couldn't get this ready. So I'm going to have to make up some problems. I think I'm going to start with this problem that we did right here today, you guys. We're going to call this one p of x. Can someone read that to me when I go back to this other slide? What was it? We're going to call it p of x equals x cubed
Minus 3x plus 3x
plus 3x squared minus 5x minus 39. Okay. All right. So let's say we have this p of x right here. So that's our p of x. Let's go back here. And a number a. What do you think our number a is going to be? Think back to that problem. Because I want to have a number that's is actually a solution to this equation. It was 3, wasn't it? If we go clear back to the start. If I go back up here, it was 3, right? We use 3 right here to divide into it. Okay, so I'm going to make a is 3. Okay, so we'll go back to this thing right here. The remainder on division by x minus a is p of a. So p of a is equal to 0. Okay, and that's what we did. So I'm going to write this again as x minus 3. That's my factor, isn't it? If 3 is a solution to this, then x minus 3 is a factor. Okay? Going back here one more time, it says the remainder on division by x minus a is p of a, so that p of a equals 0. In other words, if I did p of 3, it should equal 0. Shall we check it out to see if it works? P of 3. What does P of 3 mean to do? Yep. So I go right here. 3 cubed plus 3 times 3 squared minus 5 times 3 minus 39. Let's check this out. 3 cubed is 27. 3 squared is 9. 3 times 9 is another 27. 5 times 3 is negative 15 minus 39. Well, 27 plus 27 is 54. And negative 15 minus 39 is a negative 54. And so 54 minus 54 equals 0. This is part of what you need to know about the remainder theorem. If you plug a number in for x and you get 0, then you know that number is a solution to that polynomial. Well, I already knew because we use this problem back here. So I knew that 3 was a solution of it. That's why I used it. Okay? So going back down here, when we plugged 3 in there, we got 0. And I knew we were going to get 0 because I knew that 3 was already a factor of this, right? It was a solution. And x minus 3 is a factor. Does that make sense? We kind of get that idea? We're not done. I'm going to show you this. It's so you can check. We're going to use the remainder theorem to solve some problems here in just a second. Okay. That's exactly what it is. If it's a root, it's a solution, right? And if you plug it into this equation, you should see that the remainder is 0. Therefore, we know that 3 is a root or a solution for this problem. Okay? All right, so going back to this definition, let's finish reading this definition. It says, the remainder on division by x minus a is p of a, so that p of a equals 0, if and only if x minus a is a factor of p of x. So that completes it. We're saying that x minus 3 is a factor. We're saying that 3 is a root. Therefore, x minus 3 is a factor of p of x. Got it? Yes. Well, the definition was using the letter a. Okay, for a polynomial p of x and a number a right here. Yeah, well, yeah. Well, x is our variable. We're saying that we're going to plug in a number for x. So a stands for a real number. Okay? So in this case, we chose a to be 3. The remainder on division by x minus a is p of a. So p of a equals 0 if and only if x of minus a is a factor of p of x. So we plug in a to check. Now what if I go back to this problem right here and I said, well, let's check to see if let's see if 2 is a solution. Okay? So let's do that right now. We already know it's not, right?
Yes.
But the important thing here is we're going to find out the remainder. Yes. Yeah, you could guess and check, but would that be, a lot of times that's not a very good way of doing it. What you could do is you could put this into your calculator and you say, hey, that looks like it's crossing the x-axis at 3. So you can now put 3 in there and see if it really is, and see if it comes out to be 0. You can do that instead of synthetic division, just to check to see if it's a 0. But synthetic division gives you the quadratic, too, that you need to finish solving it. But if you were just checking to see if 3 was a solution, then that's all you'd have to do. Okay? Yes? Tracing on... tracing's not always exact. This sometimes is faster, too. But we're also trying to teach you guys a point about remainders, too. So I'm going to finish the lesson right here. Let's see if we have p of 2. Okay, we want to find 2. So we're going to plug 2 in there. So it's 2 cubed plus 3 times 2 squared minus 5 times 2 minus 39. Now, we already know that 2 is not a solution because we've already done this problem and solved it. So we know we're not going to get 0. We're going to get a remainder. Let's see what we get. 2 cubed is 8. 2 squared is 4. 3 times 4 is 12. 5 times 2 is 10 minus 39. So 8 plus 12 is 20 minus 49, right? So what do we get? Oh, wait, negative 29, right? Sorry. Negative 29. Got it? Okay, 20 minus 49 is negative 29. Okay, so we obviously, 2 is not a factor, but 29 is our remainder if we divided it in there. Okay, yes? Could we put the complex number in there? Yeah. So let's try it. Let's try it. What was one of them? 2i and negative 2i? This was the first one, though. No, the very first one. No, no, that was the second one we did. What was this answer? This one was right down here. Whoops. Negative 3 plus 2i. Let's try negative 3 plus 2i. What? 6 squared is 36? You got order of operations says you have to square before you multiply. Okay. Okay, so what was that number again? Negative 3. We're going to do p negative 3 plus 2i. So we're going to go like this. We're going to go negative 3 plus 2i cubed. This might be a long problem. I don't know if we want to do it. Okay, plus 3 times negative 3 plus 2i squared minus 5 times negative 3 plus 2i minus 39. This is going to be forever. Do we really want to do that? I promise you it comes out to be 0. You guys believe me? Anybody, I'll tell you what. If you want to know bad enough, anybody wants to come in the last 10 minutes of lunch today, we'll do it. I'll have you get up here and write it down while I help you out on it. So, okay? Yeah, for fun. For fun. Anybody wants to do it for fun, you can come in. Last 10 minutes of lunch. Okay? So, I know someone's going to be in here. Probably be Jolie and Cheyenne. Okay. I'm going to get on the intercom and say, anybody wants to come out and find out if negative 3 plus 2i is a solution to, and you guys come down here, okay? Okay, so all right. I'm going to hand you guys out your assignment. We are going to do, oh wait, I need to write out a couple more things for you right here. Okay. Okay, so we have P of X. What you guys need to know one of the things you guys know is that P of X is equal to Q of X times by X minus A. You need to know that, okay? In other words, Q of X is, Q of X, you remember when we were doing the 14 divided by 3 problem? Or actually it was 13 divided by 3 we started off with. When we did 13 divided by 3, we got, actually we divided by 4, yeah. 13 divided by 4 was 3 with a remainder of 1, right? Well, see this 3 part? That's like Q of X. If I divide P of X by X minus A, I would get Q of X plus the remainder. And I'll add that on here in just a second. But Q of X is like the 3. It's the number you get before the remainder, okay? So if you take the remainder, you take the number you got times by the factor you put in there, then you should get the original equation, right? Okay, so like for instance, when we did 16 divided by 4, the solution is 4, right? So if we took 16 would be equal to 4 times by the divisor, 4, right? Okay, this 4 right here is that 4. And this 4 right here is that 4 right there. Okay? And so we get something like that. Maybe I should use one that's a little bit different than that one. So the q of x is what you get when you divide x minus a into p of x. And if you times q of x by the factor, you'll get p of x. That's if the remainder was 0, right? What if the remainder was not 0? Then you're going to get something a little bit different. Then you're going to get this. Then you're going to get p of x equals q of x times x minus a plus your remainder, which is p of a. Remember when we did p of a, we got a remainder of negative 29 on that one problem? Okay, when we put 2 in there, because 2 had a remainder, 2 is kind of like that problem. So, what was our original problem again? X cubed plus 3x squared, is that what it was? Minus 5x minus 39. That's p of x, right? Q of x would be what we got when we divided it in there. And let's just do that really quickly. We divided 2 in there, right? So we're going to divide 2 in there synthetically, because I got to show you this. If I divided 2 into it synthetically, we had 1, 3, negative 5, and negative 39. Bring down the 1. 2 times 1 is 2. Add, you get 5. 2 times 5 is 10. Add, you get 5. 2 times 5 is 10 again, and you get negative 29. That's what we got as our remainder, right? So x squared plus 5x plus 5 is q. So we're going to take q. X squared plus 5x plus 5, that's q, times by, what was our factor, you guys? What's our factor? No, well, 2 is the solution, so how do you write it as a factor? X minus 2, that's right. X minus 2 times by the remainder. What's the remainder? Negative 29. Add, sorry, you do. Add. I was out of room, so I was trying to see how I was going to cite. Negative 29. Okay, study this out. Write this down right here, you guys. Write this up here. Write that. Here is an example of it. Okay? This part is p of x. This part is q of x. This is the factor, x minus a. And this is the remainder. This is the remainder theorem equation. It's just saying if you take a polynomial and you divide a number into it, it's equal to what you get when you divide the number in it times by the number you divided into it plus the remainder. Okay? So we get this down. Yes. Plus a negative 29. So a polynomial p of x is equal to, let's say I took 2, in this case I took 2 and divided it into it, is equal to what you got when you divided 2 into it, times the factor, x minus 2, plus the remainder. That's what it's equal to. If you multiplied this part right here by this part right here, and then added negative 29, you would get what we started with right here. I came up with a number. Huh? It's showing you how it breaks down so that you can do it. It's just like in real numbers. What's the point of having, if I divide 13 divided by 4, what's the point of knowing it's 3 remainder 1, 3 1/4. Okay? So you can solve problems. Okay, now I am going to give you guys the assignment right now. We're going to go over a couple problems. Number 1, if p of a equals 5, so we have p of a equals 5, is x minus a factor of p of x? Is x minus a factor of P of X? That's the question it asks you. If P of A equals 5, is X minus A a factor of P of X? I'm going to give you guys 1 minute to discuss this in your groups, and then we're going to talk about it.
Just like what we did earlier, how x equals 2, that's the same as 0 minus x minus 2 equals 0. Since it's like x minus a equals 0, then a equals 5.
Coulter is shaking his head behind you. Ask him why.
They agree with me.
He's great. Anybody disagree?
I disagree.
Why, Trevor? Let's be. Hey, think about this, you guys. Okay, hold on. Look, you guys. Definition. For a polynomial P of X and a number A, the remainder on division by X minus A is P of A, so that P of A equals 0 if and only if X minus A is a factor of P of X. If it's going to be a remainder, P of A equals 5, not 0. So look, if P of A equals 0, you guys, it's not saying that A is 5. It's saying P of some number is equal to 5. If this is if X minus A is going to be a factor, because this A and this A are going to be the same number, then that number right there has to be what? If it's going to be it has to be 0 if it's a factor of it, right? And it's not 0. So this one right here, the answer is no. And then tell the reason why. No, because why? Yeah, because P of A is not 0. Okay? Do we understand that? Okay, go to problem 2. Problem 2. Okay, so you're given if x squared plus 4x minus 2 over x minus 3 equals x plus 7, remainder 19. Remainder 19, rewrite x squared plus 4x minus 2 as q of x times x minus a plus p of a. So you're going to write, this is q of x times x minus a plus p of a. Okay, in other words, you guys, you're taking x squared plus 4x minus 2. X squared plus 4x minus 2 is p of x, right? So we got that part. So what we need to do is write this part. What part is q of x, you guys? No, not the remainder. What you got when you divided x minus 3 into it. You're dividing x minus 3 into it, right? So what's x minus a? Yeah, it's x minus 3, because x minus a is your divisor, you guys. I'm dividing by x minus 3. X plus 7 is the q of x, because that's what you got when you divided the x squared plus 4x minus 2 by the factor x minus 3. Plus, p of a is the what? Is the remainder, just 19. Well, if you put 3 into this, if you did p of 3 into x squared, so 3 squared plus 4x minus 2, you should get 19. So that's 3 right there. So 3 squared is 9, 4 times 3 is 12, minus 2. So 9 plus 12 is 21, minus 2 is 19. That's your remainder. Does that make sense? Okay. So you guys, p of x, look. P of x was x squared plus 4x minus 2. That's what you're divided, the number you divided, right? X minus a was the x minus 3. So a is 3.
Substitute that equation in for that equation.
Q of x is this x plus 7 right here. And p of a is the remainder. Because I told you, it's a definition. Guys, this is a definition. This is nothing other than definition. Some of you need to spend some time thinking about it. That's all you have to do. And you'll get this. Okay? Yeah, thinking. I know that's going to be hard for some of you. Okay?
Now, how do we solve?
All right. All it asks you to do is rewrite it. This is my answer right here, you guys. It says rewrite. You know, if you divide a polynomial by a factor, you get x plus 7, remainder 19. Rewrite it in the definition form. Said rewrite it in this. It wanted you to rewrite it in this form right here using the numbers that we actually used.
No, it says rewrite, and it also says.
Oh, it says rewrite x squared as q of x plus x minus a plus p of a. What is a? A is 3, you guys, right? A equals 3. A is the number you divide it into. Hey, you guys, next time I'm going to record those assignments for sure. Okay?
So wait.
A is just 3.
Is that because there's a negative here too?
Yeah.
That's so it's
Well, if you said x minus 3 equal to 0 and solve it, you get x equals 3. It's always going to be opposite of that sign. Okay?